Greetings everyone. I am Kartik Gupta from Electronics and Computer branch.
I am Jashan Pahwa from Electronics and Computer branch.
I am Vaibhav Khanna. I am from Electronics and Computer branch.
My name is Manmeet Kaur and I am from Electronics and Computer Engineering. Online shopping is so much in trend, but people are confused. How will they look in particular clothes? So the aim of this project is to develop a framework where person can upload its image as well as required clothes image and then get a desired result. The model we have used for this is adaptive content generation and preservation network. Now, before going into it, let us see what the problem statement is.
Due to the rapid growth of technology development, our daily life is heavily affected by smart systems which facilitates our activities. For instance, online shopping grew up very fast. An issue for buying clothes online is that client cannot try the products before getting it. This is where virtual try-on system is needed. Objectives. The objective of virtual try-on systems is to simply align the user and the cloth models with accurate position, scale, rotation, and ordering in order to create a virtual image with the exact same pose of the person with the clothing article superimposed with fine scale details such as prints, patterns, etc. Coming to the novelty of work, many methods are already introduced but do not produce images conclusive enough to judge whether to buy the product or not. Also, most of the methods do not have accuracy more than 35 or 40% and do not preserve the character of clothes such as textures, logos, and embroidery. Hence, the novelty of proposed ideology lies in the fact that ACGPN model will be utilized to largely increase the accuracy and produce the desired results.
Now, talking about the GAN architecture, a generative adversarial network has two parts: the generator that learns to generate plausible data. The generated instances become negative training examples for the discriminator, while the discriminator learns to distinguish the generator's fake data from real data. The discriminator penalizes the generator for producing implausible results. When the training begins, the generator produces obviously fake data, and the discriminator quickly learns to tell that it's fake. Both the generator and the discriminator are neural networks. Through backpropagation, the discriminator's classification provide a signal that the generator uses to update its weight. Although GAN was able to generate some good examples of data points, it is not able to generate the data point with the target label, and the dataset generated from it lacks diversity. The architecture of the conditional GAN was then modified by adding the label Y as a parameter to the input of the generator and try to generate the corresponding data point. It also adds labels to the discriminator input to distinguish real data better. In its architecture, the random input noise Z is combined with label Y in the joint hidden representation, and the GAN training framework allows for a lot of flexibility in how it receives input. That is all about the GAN architecture.
The ACGPN or Adaptive Content Generation and Preserving Network is a generative adversarial network for virtual try-on clothing applications. There are three modules to ACGPN. The first one is masking of body parts and masking of wrapped clothes regions, which are generated by the semantic generation module. The second the second one is the cloth warping module. It is designed to warp the target cloth image according to the clothing mask, where we introduce a second order difference constraint to produce geometric matching yet character retentive clothing images. The third one is the content fusion module, which integrates the information from the previous module to adaptively determine the generation or preservation of human parts in the output image.
Okay, now let us see the working model. In the working model, predefined libraries are imported and unzipping ACGP and checkpoints to predict better results. Vuitton dataset has been used. On uploading clothes and person image, pre-processing is done, images are resized, and then generates passing of person image. Also, pose map from person's image is obtained. At last, try-on is done and returns try-on image with background added back on person's image. The live working demonstration on Google Colab is as shown. This is the ACGPN code where we have already imported some predefined libraries. Now we'll upload the cloth image here. Now I will upload the person's image. Now resizing will be done on both clothes and the person's image. Now we'll generate their passing as well as the pose map. Now we will execute python test.py, which will save our output under image under output grid. Since it gets executed properly, now we can view our result under image grid. This is the result that it has proved. We have tested several examples. Some of them are these ones. It's an easy image which has a good accuracy. The next one is the medium one, where you can judge how clothes will look, but accuracy has been decreased. But this is the most difficult image where we need to improve the accuracy more. That is all from our side. Thank you.